Thank you. Thank you, everyone, for being here. My name is Kevin Jones. I'm a developer relations engineer working for EdgeNode, working on Graph Protocol. I'm also a core member of the Build Guild, supporting Scaffold ETH. And I'm really excited to talk to these guys today. I think I've met a few of you guys, and I'm really excited to hear what you guys have to talk about today. But maybe just we can start out with like a round of introductions, and you can kind of let everyone know where you work, what you're working on, and like how is your company kind of revolutionizing the infrastructure for Web3?
Sure. Hey, everybody. Can you guys hear me okay? Nice. Awesome. I'm Matt. I'm a developer ecosystem lead for LayerZero Labs. We are an omni-chain interoperability protocol. We focus a lot on cross-chain arbitrary message passing, so moving any arbitrary data between blockchains and doing it in a way that fits three core principles, being censorship resistant, being permissionless so anybody can come and build on top of us, and being immutable. The core contracts cannot be changed, cannot be upgraded, etc. So super excited to be here and talk with you guys.
Hello. Nice one, Matt. Thank you. Thanks, Kevin. So yeah, my name's Gavin Thomas. I'm one of the co-founders of a project called 10. And 10 is a layer 2 for Ethereum. And it's a little bit different. It obviously does scalability, low-cost transactions, but crucially, it's got an encryption component as well. So we can have an encrypted Ethereum. Might talk a little bit more about what that means, maybe.
Hello. Hey, I'm Zac. I am the CEO and co-founder of Aztec. Aztec is a privacy-first layer 2 for Ethereum, so we're recreating the programmable, composable smart contract ecosystem that we all know and love, but one where you have private state as a first-class primitive.
Cool. I'm Michael Messele. I'm from Etherspot. We provide an account abstraction solution. Effectively means we try to get the usability of Web3 to feel more like Web 2 without compromising the non-custodial aspect of your ownership.
Awesome. Thank you for that introduction. Yeah, I love that you guys are all doing very innovative things in the space. I'm hearing privacy, scalability, like these are all things that we're talking about. One thing I often hear about is there's a little bit of confusion around data availability versus actual data storage. So I thought maybe we could like let the crowd know, maybe explain a little bit of the difference, why data availability is important, and then how it kind of differs from something like IPFS or Arweave and like a data storage protocol.
Sure. For those of you who are here and saw the LimeChain presentation before, I think you guys caught part of it for data availability. For those who weren't, TLDR. Basically, the major issue right now, I think, with a lot of layer 2 blockchains is the actual ability to access block space on the base layer 1 Ethereum, right? And being able to roll up to that chain efficiently with low gas cost and being able to actually transfer those fee reductions down to the end user on the layer 2. Data storage is a little bit more with how you actually access literal data and store it on chain. So different use cases there and different needs, I think, depending on the user, but happy to have anyone here add on.
Is there also a component of cryptographic proof with data availability as well? Is that right? So that you're actually proving that the data that you're trying to retrieve is indeed the data that you're after, yeah. as opposed to IPFS, which is more just period data store.
Yeah, I do think that's true. The cryptography for how you're actually guaranteeing that that data is being written to the L1 versus IPFS for just data storage. And I believe we were going to get into a little bit here with like AWS, right? What separates decentralized data storage versus storing on like some server somewhere that Amazon owns and has in a localized location, right?
Yeah, I mean, there's definitely a difference between centralized and decentralized, and I think it really makes it it's very important to understand the difference and why it's important. And yeah, I'd love to hear more.
Yeah, I can kind of elaborate on some of the core problems, which is that for layer 1s and certainly for rollups, if the entire network loses access to some historical state, there's a very good chance you completely brick that network and you make it impossible to publish new blocks. And so data availability, these guarantees are very important, the ones that networks like Ethereum provide, because they're guaranteeing that as long as the consensus mechanism of Ethereum holds, any data that you put on that network will always be there for the life of that network. However, that is extremely expensive. So you have this weird balance where Web3 storage is outrageously expensive because of these data availability guarantees. Web2 storage is outrageously cheap because how much does it cost to spin up a Web3, an A3 bucket, S3. So yeah, there's been lots of attempts, things like blobs, 4844, to kind of bridge the gap and only have the very strong data availability guarantees for short-term storage. But that's a long topic of discussion. So yeah, don't know if we want to go into that.
4844
We can
does
get into
that,
it. We
right?
have time.
The Denkun upgrades achieved the blob
Yeah.
storage. Oh, cool. Okay. Yeah.
Yeah.
Right.
The blobs are live, guys. The blobs are live.
We blobbing.
I can't add more to this, guys. So it's either you want security or easy scaling. Easy scaling, you lack security if you put it into Amazon, and security is important for you, then you have to pay. It's on the blockchain. So the Denkun upgrade makes it cheaper, but it just went live today, so I wouldn't be able to give more details as much as you guys can.
The fee reduction is pretty incredible. I'm sure you guys have probably seen on Twitter. There's like comparisons, I believe, for either Base or Arbitrum, where it went from $1.34 to do like a bucket of 10 transfers to now being a fraction of a cent, right? So huge improvement, and again, huge improvement for L2 usability and what applications actually are now feasible and not ridiculously expensive for the end user.
Can I make a prediction? So at the moment, it is very, the cost reduction is dramatic, but a part of that is the novelty, because blobs have their own fee market.
Right.
So you need layer 2s to actually migrate to using blobs to create demand, which will then increase the fees. The way I see it, it's like highways. You know, if you've got a traffic problem in your city, and you build more roads, what happens is you just get more cars, and your traffic is just as bad, or if not worse. And something that the entire community is going to deal with is that with the number of L2s coming online, the rate of demand for data on a layer 1 like Ethereum is going to massively outstrip supply. So the way I see it, the current solution, it's quite a short-term solution, and I do appreciate there's longer-term plans with full tank sharding, and I'm very hopeful for that. But this is also a reason why you have so many data availability solutions, third-party ones like Celestia, coming on stream to satisfy this anticipated future demand.
So, sorry, go on, Michael.
Just a question for you guys. How do you guys think this affects builders? Because I was watching a panel yesterday, or the day before yesterday. Some of the builders were saying it's more like a wait and see whether we get involved in this. So how do you guys think the impact of that?
I think I can jump in first. Kind of like what you guys were all saying is that this does seem like a short-term benefit, right? Gas reduction probably won't remain forever as these fee markets adjust and people learn kind of how to arbitrage the system correctly. But I do think that assuming kind of this milestone pathway has been accurate for what the Ethereum Foundation sees, with tank sharding improvements and new ways of kind of, acquiring block space for these layer 2 blockchains, I do think that there will be sizable improvements that come down the line. And at the end goal, right, all of this is being done to incentivize builders who have applications that do need, strong data availability guarantees, but also abundance for whatever they're writing the chain. It unlocks a lot more use cases that we probably haven't seen before that involve more intense data writing direct to chain. I am kind of curious, though, how this competes with IPFS and whether or not IPFS kind of fits that void already for a lot of builders. I'm not as familiar with it myself directly.
Yeah, it's an interesting thing because, like IPFS is kind of this, interplanetary file system that everyone can contribute to, and there's a lot more complexity to keeping those files available. But I wonder, where do you think people will go in terms of functionality for these blobs? Do you think that there will be some innovation there for other things than just the layer 2 rollup stuff, or you kind of hinted at it?
I'm curious if anyone else has some thoughts.
Well, I suspect that any kind of innovation that utilizes this blob space is going to end up being called a rollup, because of effectively what's going to happen is, we'll see. It's going to be tricky because as rollups grow and become more popular, more widely used, they're always going to have more purchasing power than a non-rollup application, right? Because if my transaction's got 1,000 transactions wrapped up inside it, I'm prepared to pay a heck of a lot more likely than one person who wants to, put Encyclopedia Britannica on chain. I can quickly talk about the IPFS blob on-chain data situation a bit. I think they're very complementary because you don't want to rely on IPFS for your data availability because there are reliability issues. But let's say you're a layer 2, you're publishing blocks on layer 1, you're using a strong data variability solution, but that data is going to disappear in about 3 months, or maybe less. Is that okay? I would argue, yes, it is. Because when it comes to the historic state, the chances of it kicking around somewhere in an S3 bucket, like as a torrent, in some peer-to-peer network on IPFS, it's almost guaranteed, as long as that network is somewhat widely used, as long as you have groups that have an invested interest in caching their data. And in that kind of scenario, I think it is very reasonable for IPFS to be the default access mode for long-term storage, and you only use strong data availability solutions for short-term storage, if that makes sense.
Yeah, anyone else have anything to add there? No? So another topic that I'd like to kind of dive into is we've seen a huge rise in layer 2s and some layer 1s. And I think there is some usability nightmares that are coming out of it. The bridging problem, everyone's trying to figure out making it easy to bridge ETH. And we also have this other idea where there's SDKs and APIs being built for interacting with different layer 1s and L2s, which can kind of lead to like vendor lock-in. I'm wondering how we can collectively kind of come together to make it easier for users and for developers to use and build on Web3, and what your guys' thoughts are there.
Who's account abstraction, guys?
That's your question. This is all for you.
So, I mean, account abstraction helps in a big way, and because you are using programmable smart contracts where you can use session keys to access a specific dApp or note and expire it, and you can have spending limits and all those sorts of things. And we've seen some innovation recently, whether they will take on, we'll see, the SGX transaction executing environments where Suave sort of thing have done it, and I've seen some experiments that might be able to help us to navigate the gaps between the different chains that you have. Obviously, bridging is an issue. It's a massive issue. As a user, I can't be asked to jump in from one island to another island and use another currency. So, and the liquidity availability, in fact, is how about a paymaster making, say, if I have some funds on Polygon and I go to Gnosis, what if the paymaster allows me to pay for the gas from the XDAI I have on Polygon and automatically making it available? I mean, these sort of things are closer, but in terms of making liquidity availability, I think we've got some work to do, but you guys might have a lot more to say.
Yeah, I think diving into like a little bit deeper too, one of the core problems is that if you believe in the app chain thesis that there's going to be millions of rollups across various L1s, L2s, whatever they may be, there is an issue of having a common language for communicating between all these kind of islands. And the way you can kind of picture it in your head is that maybe these L1s, L2s, for example, like the OP stack that has all of their app chains on top of it, the Avalanche subnets, the Polygon supernets or CDKs, they all have their own common language for communicating between each of their subnetworks, right? And then to actually bridge between different islands and protocols that are existing, between these different providers, you might need some common language there. And so LayerZero, at least our bet from like the actual arbitrary message passing layer, being able to move raw data, raw information, is that it's likely these app chains will begin to use more and more these kind of native solutions that are used for app chains directly from their provider that they're reading from. But to move information directly, let's say from an app chain out of Optimism into a subnet on Avalanche, there needs to be some generic transport interface where you can say, all right, I know what the common layer is from Optimism to Avalanche. All I need to do is follow the network semantics there. And really for us, I think we kind of touched on it, this space moves so fast. Validation techniques that were thought of as impossible 2 years ago are suddenly a lot more usable. Zero-knowledge light clients, for example, right? Having a common standard for this transportation layer that is immutable in sense of what the interface you use to communicate with is, but the validation technique is modular, I think provides a lot of good opportunity for developers who are on these different subnets or app chains or whatever they may be to seamlessly communicate using whatever the network semantics are of their sub-architecture, and then pass that message through on the transport layer for kind of these larger hubs, right? I think that is probably a lot more feasible for developers where they're not kind of locked into any one validation scheme to move messages, but they still have those liveness guarantees, right? That their messages are going to be delivered, and there's no censorship censorship from the transport layer itself.
Yeah, it is a bit of a mess at the moment, and I think what you're describing, Matt and Michael, are probably good solutions. One thing I'm going to put out there, I'm not an expert on AI at all, but I know it's getting talked to a lot more and more. I do wonder if all the complexity is going to be abstracted away by using AI agents at some point, so that we can forget about how complex things are, because the AI agents will work across all the complexity and just take it away. Don't know, future guessing.
Yeah, I'm much more skeptical about AI personally, because AI is lossy, as in it's great for applications where you're comfortable with an error rate, like conversation, where if things are like missing in the flow of the conversation, grammar errors, you fill in the gaps. Same with image generation. If there are artifacts in the image, who cares? For things like moving money around, you can't reason with an AI agent about what it's done, so which might be a problem. But what's really heartening, I think, about this conversation is how many people here and in the wider community are working on solving this problem, right? Because there's money on the table for people who can. Nobody wants all this fragmentation of tokens. It'd be nice if you can just instantly, using tooling, using the correct APIs, just get that swapped in for the relevant currency on your network, which is great because this is a problem, and I have no intention of solving it. I plan on using another solution that somebody else has built.
Yeah, good side note there on the AI piece. I'm not sure if any of you have seen AI like ChatGPT try and play chess. It just hallucinates moves left and right and doesn't keep track of any state. So there probably is, I think, like a good middle ground where maybe there is some type of like data set training or way to kind of build its techniques about what exists there. But the problem is like the speed of innovation, right? As soon as you get it trained on what's available and what's consistent within the ecosystem, something new comes, and then that AI is immediately front-run or arbitraged. So I really am bullish on what we're talking about right now, right? Like coming up with maybe not uniform semantics for everything, but clear-cut standards for how you can move arbitrary data, because that ultimately rolls up to the end user of making it a lot clearer and easier to abstract away these complexities of needing, for example, different destination gas tokens, needing to worry about the finality of my messages or that they're even being verified. Making sure basically that there's a common language that we're speaking, or at least some common hierarchy of rules for predictability on how messages are being moved, right? But yeah, it is a very difficult and valuable problem that's worked at being solved.
I just want to know when Dali's going to learn to spell. So, okay, those are really great, interesting topics. I also want to dive a little bit, it's probably more of a question for you. We're going to talk about blockchain interoperability and composability. More importantly, like, what needs to happen in terms of like a global state to make blockchains fully interoperable and composable? And how important is that, or what else are you thinking about when it comes to that?
It is a loaded question, right? It's really tricky because at a core level, when you're trying to move anything between blockchains, you're trying at best to not validate the security assumptions of the underlying chains, right? So you need to at best keep the security properties of the core blockchain you're building on top of, but those chains actually introduce new vulnerabilities for the messaging layer itself. For example, block reorgs. Some chains, they don't have this issue pretty much at all. A block is confirmed almost instantaneously. Other chains, the block can be reorged up to 256 blocks. And so what that means for a user is that I could pay for something on a source chain, and if my messaging layer isn't planning for it, deliver that message even though it gets actually reverted on the source chain and it's no longer final. So you paid for something, that payment got rejected, but you still received the goods at the end of the day on the destination. It really is a tricky problem to solve, and so for us, at least the way that LayerZero is positioning it, we want to keep kind of the core three principles of censorship resistance so that anyone can build on top of the protocol, have immutability at the contract level at least so that the interface is consistent, that you're always going to operate between. Socket, for example, it ran into this issue, right, with Socket, with the vulnerability that happened, I believe, a month ago. They have upgradable contracts. They pushed an upgradable contract for one destination pathway that had an open call function in it, and an attacker realized that, hey, you approved this socket contract to spend tokens on your behalf. There's an open call here. I can pass anything I want into it, and then rugged all those users out who had approved those tokens. Upgradability is really dangerous in the cross-chain world because once it's upgradable, you can't take it back. So I think to, I guess, sum up like what interoperability needs is, I think like strong liveness guarantees that the protocol is never going to go down, and this probably correlates back to our conversation about data availability. It also needs to ensure that anyone can interact with it permissionlessly. There can't be a way for me to vendor choose basically each individual that interacts with the protocol. And then again, censorship resistance, at least at the protocol level, so that when you're building cross-chain applications, it's similar to as if you're building on one chain, where you can extend contracts however you want and obviously add features and access control afterwards, but the core protocol itself is unopinionated about how you use it.
It's a great answer. Yeah, I think that it's, I mean, you've articulated some of the fierce challenges, and it is, you know, I'm not sure I can add on to the potential solutions, but I do have another angle, which is, this may be unpopular given we're in a bull market, but I think the problem is going to become easier over time because there's going to be fewer chains one will want to interoperate with. I look at, you know, Darwinian evolution. No two species can inhabit the same ecological niche and coexist. One will always outcompete the other and devour it. And so the question on my mind is, what are the unique value propositions for all these networks? They're going to have to distinguish themselves in some way, or some of them are going to die. And when that happens, well, it'll be easier.
From what you're saying, a lot of them have to die because in terms of the EVM world, when you count the old L1s and L2s, there are over 100. So
Our money on Ethereum. Our money's on Ethereum. It's the only one.
I do think that's a really like good point, though, that right now it may seem like the limit of chains is limitless. You can have infinite chains that are always going to have their each niche, but you're probably right that as we kind of learn what chains have better guarantees in terms of like cost, in terms of security, in terms of efficiency, speed of actual transactions, this kind of diversity will probably begin to niche down even further, and only a few of them will survive in a meaningful way, right, for the core user. And even then, with what you were talking about with account abstraction, the end user might not care, and so there might be even another level that's cut just because they're not different enough to actually matter. And so I do think that there is a level of chain development that probably gets cut, but at the same time, we're still building new chains and adding new VMs, new ways of building on top of just ledger technology. And so I'm curious, like, do you think we're past that mark? We're on the downhill of like cutting chains out, or we still are on the rise up where more and more chains are going to be coming out day in, day out?
Yeah, no, we're on the rise. I feel like that, yeah, what's really missing is some coherent open standards for interchain operation. And I think once some of those standards start to be developed and gain a little bit of traction, it's going to have a very rapid effect where the chains that adopt those standards are going to be plugged into this interoperable world, and the chains that don't are going to have a very hard time.
So just to ask a question, then what do you guys think then, in terms of as a user, I can't really care less what chain I'm dealing with. I just want all my data, and I want the best offers. And I also wanted to understand my intentions, so hence intents. So how do you see that panning out with the proliferation of L1s and L2s and maybe reducing? So
infrastructure. Yeah, you know, when like one of the key goals, right, is to make all this technology mainstream, so that it's fundamental infrastructure technology that people use when they're accessing goods and services, and they don't even know about it. Even the people building the services likely won't know about it in the same way that, you know, like how many devs know about the intricacies of the IPv6 protocol? It doesn't matter. And so, yeah, I feel like we need some more abstraction layers. We're still really early in this whole journey. But with those abstraction layers, yeah, you'll be able to build apps, deploy them, and what network you're deploying on is going to be abstracted, and the users aren't even going to be aware they're using a blockchain.
Yeah, I think that's a really good answer, too. And I think there's actually a core question here, because I see this happen a lot when people are presenting or building new products out in Web3, is that they don't understand like who the core audience actually is for the product. There are a lot of different user sets within Web3. You have the actual infrastructure layer, and so you're probably targeting core developers who are going to be implementing applications themselves, but it depends on what kind of application, right? And you can even go further up that like hierarchy tree of applications, and you get to a point where each application on top of another is a little bit more abstracted and cares a little bit less about what came before it, right? And so your core user for a wallet is probably an end user who's buying tokens, but a core user for an arbitrary message passing protocol is probably like an app developer who's trying to build some new primitive across multiple chains. So honing in and kind of figuring out who is the user changes your answer on like what they actually see behind the curtain of Web3, right? So for account abstraction, I totally see it where this concept of a chain goes away. We think of it maybe more of like TCP/IP for the internet. We don't really care how these different websites are connected. We just know that they are. And then everything else before that is obviously available and you can learn about it, but it's not relevant to you necessarily building on top of.
Yeah, I think that makes a lot of sense. In general, I think that's when we'll really see mass adoption, where people are not going to care so much about that and just focus on building on top of it. So great. Okay, so now I want to talk a little bit about, it's kind of a two-part question. First, zero knowledge proofs is a bit of a buzzword right now, but it really does aim to solve a really important problem, I think, in the space. The first question is like, is zero knowledge proof close to being in a fast and affordable and reliable infrastructure, or like a way to work in the space? And then on top of that, if not, is the concept of intents and solvers going to be the short to medium term way that we handle those kind of like roll-up transactions and whatnot?
Guess as the resident ZK person, I should tackle this. Yeah, I mean, it's great to see like the proliferation of ZK. I was at ETH Denver, and 20% or so of the booths are all doing ZK stuff. The site saying ZK is the future. I was doing ZK 6 years ago. 2018, where it was a very different thing, a different environment, where I didn't even use the term ZK because people would be like, what is that? So yeah, get off my lawn, basically. Yeah, it's interesting. I think to answer your question, ish. There are still fierce security issues with zero-knowledge cryptography. A lot of the tech isn't really fully audited. It's not been fully battle tested. A lot of the security assumptions haven't been properly tested. A lot of the ZK layer 2s are running centralized provers because, well, one of the reasons is there's a little uncertainty that if you just allow anyone to submit proofs, that you're not going to get wrecked by someone finding a bug. We've experienced this ourselves when we had Aztec Connect live. I think over its life, which was like 18 months, 3 critical vulnerability bugs were reported to us that we missed through extensive internal and external audits. So it's getting there. For some applications, I think it's ready. But generally, I think if you're not using the privacy aspect of zero-knowledge proofs, you're not actually proving statements on encrypted data. There is always going to be an alternative mechanism using intents or economic game theory that's going to be easier to deploy. And so it's very much a question of what is, for today's technology, what's the right solution? And we're still figuring that all out.
Yeah, because there is technology that exists now that is ready for today for encryption. And I don't want to fight you, Zac, but it's probably secure enclaves.
Ooh. I mean, I'd love to have this discussion, but I don't want to hijack the whole panel.
Yeah, we're getting close to the end here. We don't want to go too down the rabbit hole. So, anyone else have anything to add there?
Yeah, I can't speak for intents from whether intents or ZK is the future. I think I can speak for it, though, more from like an interoperability standpoint. I think that going back to, again, the core problem of interoperability, it is kind of a kicking the can down the road solution where a lot of it is placed on like the solver itself. And there's a assumption sometimes made that, oh, well, we don't have to worry about how this market making is done because the solvers will eventually do it and we'll have a marketplace of solvers. But we don't really know for sure where all those solvers come from. And if you look at a lot of the implementations that are existing today, at least for interoperability, a lot of that solving marketplace is centralized. Like majority of them are coming from one provider, and there is liveness concerns that if you're trying to send a message, how do you guarantee that solver isn't working behind the scenes against you to reorder messages that are favorable for them? How do you implement it in a way that you know that it's still upholding kind of the core cryptographic primitives that you need them to do? And so I think that it is a short to medium term solution that people are using, and I think it's very, very cool that people are experimenting and seeing what works. I don't know, though, if it really solves the core problems with interoperability, because it does have like concerns with liveness in the short term, and in the long term, it just hasn't proven out yet whether or not there are enough solvers and enough marketplace demand where you can do this in a way that is fully transparent, that is permissionless, that isn't kind of working against you or could be censorable.
Yeah, and I think it's also a really difficult thing to solve from a decentralized perspective as well, right? I know there's a lot of projects working on that, but yeah, it's a tough one.
Another like $1 million idea if they do find the perfect way to do it, right?
But I mean, I do agree with Matt. There are a lot of caveats. However, as you said, quite a lot of teams are experimenting with intents, because the usability or the unusability of Web3 is just out there for everyone to see. So we've only got a niche space in the DeFi compared to the overall market that people can use. So making it usable is a driver. And as you said earlier on, there is money on the table. But whether that would be a solution 5 years down the line, that's another question.
I will make a prediction though. So I think ZK right now is it's emerging technology. In 5 to 10 years, it's going to be everywhere. It's going to saturate our lives, and we won't even know about it.
It's going to be like blockchain 2.0.
Oh yeah.
Great. So I want to hear from each of you a little bit about what your plans are from a development perspective on your products, and maybe you give us a little bit of insight on your roadmap and what you guys are working on and thinking about for the future. You want to start?
Yeah. From the account abstraction angle, we're looking at the intent side and cross-chain operability as well, how to leverage the smart accounts and improve the usability, because there's so many island hopping that we have isn't working for us.
Yeah, in terms of what we're doing, imagine you can write a smart contract and you can write private, and it means that. You can create end-to-end encrypted transactions. We want to rip out, provide an abstraction layer which hides all of the cryptographic nonsense, so that engineers, devs, they can use this tech. They can deploy smart contracts that have privacy-preserving properties, which explodes the design space of what you can do with a smart contract. So that's what we're building. That's what we're grinding on. It's been 6 years, and we're hopefully going to get our testnet out, end of Q2 this year, and we'll have some very, very exciting news hopefully by the start of 2025. But yeah, we're grinding, we're building.
Woo.
So I've got to be careful what I say here, because I don't want to score points against Zac, because what you've described, I couldn't agree with you more, where when you write in a smart contract private, it actually means private. And that's where we are with our testnet at the moment. So because we're taking a slightly different approach to our encryption, that's where we're at. Testnet's out there, ready for mainnet later this year. I guess delivering 4844 out of the box for us is now high priority. And the concept of app chains, so not too dissimilar to sub networks and sub chains, could be quite interesting for an encrypted layer 2 as well. So it's going to be a busy year for us.
Yeah, from the LayerZero side, we just launched LayerZero V2, so we're now live across 50 plus chains. For us, V2 meant there's a huge amount of improvement built upon the base protocol for how do we actually enable this kind of actual like cross-chain primitive itself, being able to move messages seamlessly, have strong guarantees for liveness, and have app developers not be locked into a one-size-fits-all of cross-chain interoperability. What comes next for us is really about getting people to build on top of us and kind of push the limits of what you can do on the protocol. We currently have an OAP standard, so you can move any arbitrary data as bytes to the destination chain. You can, pack multiple calls, so you have composability where I could send from chain A to B to C. All of the gas is abstracted for the first user who makes the call. And we have a lot of people who are building on top of us. ERC 6551 was just announced at ETH Denver, built on top of LayerZero. The goal really is to kind of get all of these common implementations and contract standards that exist kind of in like the ether out there to start locking into, or not locking in, but start using LayerZero to really kind of unlock what is possible for cross-chain interoperability. I think that there's still a lot to do from like the verification schema standpoint, right? As new techniques become available and widespread and people use them more and more, providing those as a native decentralized verifier network as part of the protocol that you can select, and getting kind of more partners aware that this is something you can do. We have an entirely permissionless verification layer that you can permissionlessly add new verifiers to. We also have an execution layer now that, totally independent of the verification, automatically will execute messages for you. Anyone can run an executor. We run one ourselves as a production asset for the ecosystem, and really it unlocks a lot more seamlessness, I think, that we've been talking about for interoperability. The way to easily send messages from chain A to B to C to however many legs down, and make sure that the messages you're executing fit those liveness guarantees and also are seamlessly executed for the end user. So a lot of cool stuff coming. Stay tuned.
Awesome. Well, this has been a great conversation. You guys have a lot of insight, and I really like what you guys are working on, so keep up the good work. And let's give everybody a round of applause. Thank you so much. And we'll start our new panel here in the next couple minutes.